Hello everybody, this video is going to be a short review on how the solubility of a substance changes based on what phase the substance is in. This is something you learned in Honors Chem, but I've noticed over the years that it is something that a lot of people tend to forget because it's not emphasized heavily. So let's do a quick review. Solids will typically have increased solubility as you raise the temperature, meaning if you heat it up, it will dissolve better. You'll be able to dissolve more and faster. The speed at which it will dissolve will increase if you do something like smash it up so that you have a larger surface area. Compare that to gases, where the solubility decreases as the temperature increases. Have you ever had a warm soda? Do you notice that a warm soda does not taste as bubbly? That's because the carbonation has all escaped because it's not as soluble. It doesn't dissolve into the soda, into the water as much. Your solubility increases as the pressure above the solution increases. So, when you open a soda can or a bottle of soda, it kind of like pops, right? We're releasing pressure when it's in the can or in the bottle. They have increased the pressure inside. It's what we call under pressure. And that's to keep the carbon dioxide bubbles in the liquid. If you look at a bottle of soda before you open it, you don't see any of the bubbles because they're dissolved into the water of the soda. When you open the top and you release the pressure and the pressure decreases, that carbon dioxide is no longer as soluble, and so the bubbles will escape to the top, and that's when you see the bubbles there. So if you heat a solid or stir it up or smash it into little particles, it'll dissolve better. For a gas, you want it to be cold and with a high pressure. We learned some words to describe how much of the solute is dissolved. Words like saturated, unsaturated, and supersaturated. Saturated is when you've added the exact most amount that can possibly dissolve. Unsaturated is when you're not there yet. You could keep dissolving. Supersaturated is weird because people don't like thinking about how you can dissolve more than the maximum amount you can dissolve. But you have to remember it has to do with the temperature that this occurs at. So to make a supersaturated solution, you would heat the solvent up. You can dissolve a ton of solute, and then you very carefully and very slowly cool it back down to a lower temperature. It's not stable though. So if you bump it or scratch it or drop a little crystal of something in there, it will do what's called crash out, which means all that extra solute will fall out and be a solid at the bottom of your container. And at that point, it will just be saturated. It won't be super saturated anymore. Very often when we're talking about how much you can dissolve in something, we use units like grams per 100 grams of water. How many grams can you dissolve in 100 grams of water? Or other solvent, may not always be water. However, please check your units. They don't always use 100 grams, so you have to be a little bit careful. And then if you want to know whether or not the solubility will increase as the temperature increases, you would need to look at the delta H of solution. If the delta H of solution is endothermic, then you will see that as you raise the temperature, you will get more stuff to dissolve because you're providing more of that energy, right, to pull those particles apart. Sometimes you'll see these curves called solubility curves. You'll see temperature at the bottom and grams per whatever, this time it's 100 grams, right? So if you're touching the line for a certain substance, that means you're saturated. So for example, at 70 degrees, you can dissolve a maximum of 30 grams in 100 grams of water. Over here, let's see, like at 20 degrees, how much salt could you dissolve? Well, at 20 degrees, you could dissolve, what does that look like, about 35? Trying to eyeball it here, about 35 grams in 100 grams of water. So you can use these curves to figure out how much would dissolve. If you're below the line, it means you could keep adding more and more and more and more until you get to the line. So anywhere below a line would be considered unsaturated. Now let's think about making our supersaturated solution. Let's say I want a supersaturated solution of potassium chloride. Let's use the dark blue line here. If I want to have, let's say, 50 grams dissolved at 30 degrees, that wouldn't work right now, would it? If you look here, we'd be above the line. But what we could do is we could take our 50 grams, heat up our solution, heat it, try to dissolve it all in, heat it up to like 90 degrees. At 90 degrees, all 50 grams would dissolve, wouldn't it? So then, once it's been dissolved, I can slowly and very carefully cool it down. Make sure I don't bump the container. Make sure no one's doing jumping jacks next to it or anything. And then I can get all the way back down to the desired temperature I want. Now let's say we bump the container. Well, what's going to happen is all this extra grams from 35-ish to 50, that difference is going to crash out. And we'll be back down here on the blue line. It'll go back to being saturated and we would have lost all that extra that we tried to dissolve. So my suggestion is when you're trying to remember your solubility based on the phase of substance, think about soda, think about the gas, and then think about maybe dissolving sugar in a hot cup of coffee or a hot cup of tea versus iced tea. You can dissolve way more sugar in a hot cup of tea than in a cold cup of iced tea. So using some of those common everyday examples can help you remember which would be more favorable. Nobody likes warm flat soda where all the bubbles came out, right? That's not good. If you think about that closed can under pressure, it crams all of those gas particles into the solution. You open that can. Now you can have more particles escape. We're back to that vapor pressure idea, aren't we? All right, another thing to think about when we're trying to dissolve stuff in a liquid is how many particles does it dissolve into? The more particles that are formed, the more affected things like your vapor pressure will be. One interesting fact is that it doesn't depend on what the particles are, just how many particles there are. So if you look here, AB starts as one particle, breaks apart into two. Compare that to over here. We have one particle, and now it's broken apart into three different things. This will have a larger effect on our vapor pressure lowering than AB did. Some things don't dissolve, do they? Sometimes they're called non-electrolytes. They don't dissolve into different particles. Sorry, they don't dissociate into different particles. So you start with one and you end with one. So if you want to make a prediction about which substance you could add to lower the vapor pressure the most, look to see which thing dissociates into the most number of particles. When you dump something into your solvent to see what happens if it dissociates into particles that can carry a charge, it's an electrolyte. They conduct a current. A non-electrolyte won't. So salt versus sugar, for example. You can use devices to see whether or not they conduct. Oftentimes there's some kind of a light, maybe not a light bulb, maybe it's like a little green or red little light on the equipment, but if it lights up, it means that a current was conducted, it's an electrolyte, and if it doesn't light up, it's a non-electrolyte. I would make yourself familiar with some of the common examples. I'm going to put some of these up, and I want you to see which of these you can predict. Think about what you know about the substances, the types of bonds, things like that, and try to predict if it's an electrolyte or a non-electrolyte. Will it conduct electricity or no? Pause the video, give yourself some time to do it. All right, let's look at the answers. Are electrolytes tap water? It's not strong, but it is because it has a little bit of ions and things in it from the tap, right? It's not pure water. Salt breaks apart into ions. Hydrochloric acid is a strong acid. It's going to dissociate. Lactic acid will dissociate, but not very much. It's a weak acid. Pure water has nothing there to carry that charge, to carry that current. Sugar doesn't. Alcohol, nope. And then I love this example. Pure sodium chloride. When it's in that solid phase, it is not going to conduct a current. However, if you heated that up into molten sodium chloride, then it could conduct. So be careful about your phases and your temperatures and things. That can always change your answers a tiny bit. All right. Well, that's it. I hope that's a little bit of a reminder about the solubility trends, how things will change based on temperatures, how much can you dissolve, how much do things dissociate, what happens when they dissociate. So hopefully that was helpful. That's it. Bye, everybody.